Hey everyone, today we're going to look at our Unit 2, Section 5, which is graphing reciprocal functions. So we've graphed sine and cosine, we've graphed tangent. Now we're going to look at cosecant, secant, and cotangent. So with all of our reciprocal functions, none of our reciprocal functions are going to have amplitudes, okay? And they will all have asymptotes. So when we look here, what I want you guys to see is that for cosecant and secant, it is the reciprocal of sine and cosine. So what we can actually do here is, if I remember that cosecant is sine's reciprocal. So my standard sine graph, if I'm graphing just the sine of theta, I'm going to go from my midline to 1, back to my midline, back to my low point, and then back to my midline. So this right here, come on, sorry, pen's acting weird. Okay, this right here is my sine graph. Okay, 0 to 2 pi, that's my sine graph. So what's going to happen is, on my sine graph, everywhere I hit the midline is an asymptote for the reciprocal function. Okay? And then my reciprocal function is what I'm going to just call kiss the highs and lows of my sine function. So where my high point is, my cosecant graph is going to be a parabola going upwards here. Where my low point is, I'm going to have a parabola going down. All right? So again, sometimes the easiest thing here to do is to actually graph your sine function, and then you can, from there, at all of your midline points, draw your asymptotes. Okay, every pi in this case. All right, and then we know that the cosecant graph is just going to flip the other direction from my sine graph. Okay, same thing with my secant graph. My secant graph is the reciprocal of cosine. So my cosine graph starts at 1. All right, then we hit the midline. Then we hit -1. Then we're back to the midline. Then we go back to 1. So right here, this is my cosine graph, okay, if of just the cosine of theta. So again, it's still the same thing. Everywhere we hit a midline, that is going to be an asymptote. And then our high points and our low points is where our parabolas are going to start. So they will touch each other. They're not going to ever overlap. So you'll see kind of that blank space in the middle for your sine and cosine graphs. All right, cotangent is just basically flipping tangent over. All right, except our tangent graph has this center point at the 0. This one is going to shift over, because remember, when we think about our unit circle, right, this was my tangent here is 0, my tangent here is undefined, my tangent here is 0, and my tangent here is undefined. Well, what's going to happen is, from my unit circle, I'm going to be switching what's defined and what's undefined. Okay, because these two were divided by 0, but when I take the reciprocal of that, the 0 becomes the numerator. For cotangent, these become undefined. So now where we used to have our amplitudes for tangent are now going to actually be points on our graph for our cotangent. All right? So when we're looking here, my period of cosecant and secant is going to be the same as the period of sine and cosine. It is still 2 pi over the absolute value of b. All right? The period for the cotangent function is going to be the same as the period for tangent. Instead of 2 pi over b, it's just pi over the absolute value of b. All right? So let's take a look at some examples over here. So I have 3/2 times the cosecant of theta. All right, remember again, the cosecant is the reciprocal of sine. So my b value here, I don't have one, so it's 1. So I'm doing 2 pi over 1. So my period is still 2 pi. All right, my increments, no matter what, we're always dividing by 4. So it's 2 pi over 4, which is going to be pi over 2. Here, I don't have a phase shift or a vertical shift. All right, my asymptote is going to be my period divided by 2. Okay, so here my period is 2 pi, and I'm going to divide that by 2 to get pi. So I'm going to have asymptotes every pi. And my midline, since I don't have a vertical shift, is still y equals 0. So I want to start kind of with my asymptotes here. I know that my asymptotes are going to be every pi. I'm graphing sine. All right. So remember, sine starts at your midline. So that is my first asymptote. From here, actually, let's thicken that up just a little bit. We're going to go here and then here. Every pi, I'm going to draw an asymptote. All right, remember, now sine is going to start with my amplitude of 3/2, right? So if I look at having an amplitude of 3/2, right, that's 1.5. So sine is going to start here. It's going to go up 1.5. It's going to go back to the midline. It's going to go down 1.5 and then back to the midline. So this is important. It's not an amplitude of our cosecant function, but it is the amplitude of the sine function. All right. So we still need that information to know where we're going to start this graph. Right? So that's really important, is if we look at that first one, even though it's not an amplitude of the function, it kind of is in a way, we still need it to work out where those pieces are going to be. Oop, drop that one too low. So then this one's going to be -1.5. We go back to the midline. We go +1.5, back to the midline. So now from here, I'm just going to draw parabolas. That was really ugly, but best you can. At every high and low point. Okay? Questions on that, please make a note of them or email them to me. Okay? So then let's look at the next one here. I have 3 times the secant of 2 theta. So remember, secant is the same thing as our cosine. It's not the same thing. It's the reciprocal of our cosine. All right. So our period is always 2 pi divided by b. My b value here is 2. So my period is pi. My increment is going to be now every pi over 4. Okay. My phase shift here, I'm not adding or subtracting anything. So my vertical shifts are still 0. My phase shift is still 0. My midline is still at 0. All right. Again, my asymptote, I'm going to take the period and I'm going to divide it by 2. Okay, so it's going to be every pi halves is going to be an asymptote. So again, we're going to start by thinking about that cosine graph. Cosine is going to start at the high point when it's positive. My amplitude is 3 for the cosine graph. So I'm going to start here at 3. And now my increment is every pi over 4. Well, if I look at this scale, each line is pi over 4. So this, I'm going to go down to the midline. All right. Then I'm going to go down to 3. I'm going to go back to the midline and I'm going to go up to 3. Okay. Then we go back to the midline and we go down to 3, back to the midline, up to 3. From here, down to the midline, down to 3, up to the midline, up to 3, and down, and down, and up, and up. Okay, so again, guys, every midline point is your asymptote. And yes, you need to draw in your asymptotes. Now, do you always need to do this many? No. Okay, as long as you do at least a couple of periods on each side, that is what I want to see. And then from here, every high point is an upward parabola. And every low point is a parabola that opens downward. Okay? Again, any questions on that, please make a note. But again, the easiest thing to do is kind of think about where that cosine graph goes, and then you can draw out your pieces from there. All right, let's look at some more. All right, this one we're going to do negative secant of 1/2 theta. So again, secant is going to be the reciprocal of cosine. So if we look at the negative cosine of 1/2 theta, that's kind of what we're going to be looking at our graph for. All right, our period is still 2 pi over our b value, which is 1/2, which is going to give me 4 pi. All right, our increment is always 4 pi, our period divided by 4. So our increment is every pi. Our phase shift, we're still not adding and subtracting, so our phase and vertical shifts and our midline are all still at 0. And then again, our asymptotes are going to be that period divided by 2, 4 pi, divided by 2. So my asymptotes are going to be every 2 pi. So then again, if I'm graphing cosine, here my amplitude is -1. So remember, cosine normally starts at a high point. When we bring it down, we're going to start it at the low point, okay, when it's a negative. So it's going to start at -1. Then I'm going to go a full increment, which is pi, and that's going to be my midline. The next point, we're going to go up to the high point. And again, we're just going -1 to 1 because that's my amplitude for cosine. And then from here, we're going to go back to pi. We're going to hit our midline. And then from here, we're going to hit our high point. So this is our cosine graph for negative cosine 1/2 theta. So then again, our midline points are our asymptotes. And then our parabolas go from here. And then this one opens down. Okay, and please guys make sure that you are trying to draw these so that they look curvy. I know I'm not perfect. I don't expect you to be perfect, but please don't make them look like absolute value graphs. All right, they should not be straight lines. They should be curves. Please, as you're drawing these, make them as curvy as you can. All right, again, I'm not expecting perfection. I got a pretty good wobble going on right here, but it is important that we are trying to make sure that they look like curves. All right. So with number 4, when we're looking here, okay, we're graphing a cosecant graph. So if we think about this as 5/2 times the sine of 2 theta, okay, we want to kind of graph that graph, at least those points, and then we'll know where our asymptotes are and where our parabolas go. All right, so our period is always 2 pi over b. So my b value here is 2. So I have a pi. My increment is always pi over 4. Again, we're still not adding and subtracting anything, so our shifts are all 0. My midline's at y equals 0. My asymptote is my period divided by 2, so it's going to be pi divided by 2. All right, so sine graph. Again, we're not shifting left and right, so I know that it starts on my midline. My amplitude is 5/2 here, which is every 2.5. So my increments are pi over 4, so I'm going to go up 2.5, back to the midline, down 2.5, back to the midline, up 2.5, midline, down 2.5, midline. And let's do the same thing on the other side. We're going up here, so we come down, then we're going to come down 2.5, hit the midline, come up 2.5, back to the midline, down, mid, up, mid. All right. So again, our midlines are our asymptotes, all those midline points. Remember, they're not always going to be on the axis. Whoops, drew that one in the wrong spot. Okay, they're not always going to be on the axis, those midline points. All right, if we have a vertical shift, they're coming up. That is why you hear me saying every midline point is an asymptote. And then from here, we're going to draw those parabolas in. All right, high points get upward parabolas, and our low points are going to get low parabolas. And they're not true parabolas because there is an asymptote, but it's the easiest way to describe the shape for you guys. All right. Okay, let's look at the next ones. Okay, 5 and 6. Now we're going to start looking at those cotangent graphs. Okay. So what we're going to look at here, remember that our tangent periods are only pi over our b value. Okay, cosine and sine are 2 pi over the b. Our period for cotangent and tangent is pi over b. So this is going to be pi over 2. Our increment, we're still dividing by 4. So it's pi over 2 divided by 4, or times 1/4. So my increment is going to be every pi over 8. Still not adding and subtracting. My phase shift and vertical shifts are still 0. My midline is still 0. So for our asymptote, we're still taking that period and we're going to divide it by 2. Okay, so it's going to be pi halves divided by 2, or times 1/2, which is going to give me pi over 4. Okay, so we start with graphing our asymptote right here. So again, with cotangent, when it does not have a phase shift or a vertical shift, our asymptote is on the y-axis. Okay, so if we have a phase shift, then we're going to move that asymptote. So the easiest thing with cotangent is to graph that first asymptote first. Okay, so then what we're going to do, things are happening. Okay, we're going to graph this first asymptote. So again, we don't have a phase shift, so it's on the y-axis. Now, I can look at my asymptotes are pi over 4. Remember, that's pi over 4 from that middle point. But with cotangent, this is easy to just ignore for right now, and it can be used as kind of a self-check. I know every period is pi over 2. So that means I'm going to come over here to pi over, and I'm going to draw another asymptote. Then I'm going to go pi over 2 further and draw an asymptote, and then another pi over 2, and then another pi over 2. And we're going to do the same thing on the other side. We're going to go pi over 2, pi over 2, pi over 2, and pi over 2. So now, we don't have a vertical shift, so our midline is y equals 0. The middle of each of these is going to be where our cotangent equation crosses the midline. So we're going to put a point on all of these spots here. Now, this is where that 1/4 pi comes in, or pi over 4. Okay, it's pi over 4 this way, pi over 4 this way. But again, it's easier just to start from the period, graph that first asymptote, and then graph your period breaks from there. Now, my increment is pi over 8. And again, it's not an amplitude, but I have a 3 in front of here. that is going to be where that next point is above and below the midline. It's not an amplitude because the graph is going to continue going above it or below it, but it's showing me where I'm going to put that next point. So pi over 8 is going to be right in here, and I'm going to go above my midline 3 and below my midline 3. Ooh, that was a random place to put that. 3. Okay? So when we're looking here, I gotta push that back down. Whoop. Technology's doing fun things. Okay, so now that I have these 3 points, this is where my cotangent line is going to go. So remember, your cotangent is going to curve in a different way than your tangent does. Your tangent curves from the left to the right, moving upwards. Okay, the cotangent is going to go down as we move from left to right. All right, so then we're just going to do the same thing here and here. Do this point and this point all the way across next to the asymptote, and then we're going to come down here next to the asymptote, and we're going to draw those lines. So that third point there is kind of where the curve happens. So we go here and we curve around, and we curve around. Oop, that's got a little extra curve down here. Straighten that out. Okay, and you would just continue graphing those all the way down. All right, let's take a look at the next one. So with the next one, okay, we have a negative cotangent, so we're still looking at the cotangent. Okay, so my period is still pi over b. Well, my b value here is 4/3. So if I'm dividing by 4/3, this is saying the same thing as pi times 3/4. So my period here is going to be 3 pi over 4. Then when I look at my increment, okay, my increment is going to take that period and divide it by 4 or multiply by 1/4. So that 3 pi over 4 times 1/4 is going to be 3 pi over 8. Again, we're still not adding or subtracting anything here, so my shifts are still 0. My midline is still 0. Okay? And I'm not, again, really worried about this asymptote, but it is 3 pi over 4 divided by 2 or times 1/2. So this is going to be 3 pi over 8. Oh, and I'm goofy. This is 16. 4 times 4 is 16. Okay? So let's take a look here. Again, I'm going to start by looking at that first asymptote. I don't have a phase shift, so with cotangent, my first asymptote is on the y-axis. Okay, my period is 3 pi over 4. So each line here is pi over 4, so I'm going to go out 3 pi over 4. 3 pi over 4. Okay, 1, 2, 3 pi over 4 here. 1, 2, 3 pi over 4 here. Okay. So then I know that it's going to cross the y-axis in the middle of that. All right. So your cotangent's always going to cross right in the middle of your two asymptotes. All right. Now, this time it's negative. Your cotangent, when you negate it, it's again the same thing as graphing your tangent line. All right. When you've got that cotangent and you negate it, tangent's going to look the same of the positive. So what we're going to do here, all right, is I'm going to split each of these pieces in half. So it's about here. I'm going to kind of like air quote amplitude. Remember, that's not really an amplitude, but how far above we're going to put that point is 1. So 1 and below, we're going to go halfway between right here. Okay? So then we can draw our lines this way. So if you can get in the asymptotes correctly, then you just cut it in half, that space in half, to find that midpoint. Okay? And then you cut that distance in half on each side, because again, we're taking our divider and we're increments of 4 here. So 1, 2, 3, 4. It's still 4 increments. So each one of these pieces is 3 pi over 16. But again, you can do it visually just by saying, okay, half the distance between the asymptotes is here. Half the distance between the midline and the asymptote is here and here. Okay? Again, this one is going to move upward from left to right because it is a negative cotangent. So let's look at the next one. Oh, shifted over. Not change page. Here we go. So number 7. Okay, we are graphing 2 times the cosecant of x minus pi over 4 minus 2. So remember, we're essentially going to start by graphing the sine of that value with that whole equation, but with sine in it instead. Okay, so my period is 2 pi divided by b. My b value here is 1, so my period is 2 pi. My increment takes my period and divides it by 4, so we're going to have pi over 2. Okay, my phase shift right here, I'm moving to this is a positive pi over 4. Okay, because what am I subtracting? I'm subtracting a positive. So this is a positive pi over 4. My vertical shift we're going to go down to, so my midline is at -2. Okay, my asymptote is going to take my period again and divide it by 2. So when I divide 2 pi by 2, I'm just going to get pi. Okay, so now we're going to look at graphing this equation. All right, and again, we're going to start by graphing this just like it was the sine instead of the cosecant. All right, so when we want to start this looking again with our midline first, just like we did with sine, we're going to look at that midline first. So my midline is shifted down 2, so I'm going to come here and graph my midline. All right, then from here, I know that sine starts on my midline. All right, but I'm shifting to the right pi over 4. So I'm going to start it right here. All right, then we are going to go pi over 2 because my increments are pi over 2. So I'm going to go over here, and I'm going to go up to above the midline. Okay, my amplitude for the sine equation would be 2. So I don't want to go up more than 2. And then we go 2 over, back to the midline. And then we go down to below the midline. And then we go back to the midline. All right, and then on this side, we're going to go down 2. Then we go back to our midline. Then we go up to above our midline. Then we go back to the midline. And then we go to below the midline. So remember, those midline points are all of your asymptotes. So we're going to draw our asymptotes through the midline points. Here, 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 and here. And then we draw in our parabolas. Remember, our high points get up parabolas and our low points get downward facing parabolas. And that is our graph. All right, let's look at the next one. Okay, with number 8, we have 2 times the secant of 1/2 x plus pi. Remember, this can be x or theta. All the ones we've seen today have been x, and what we've seen in the past has been theta. It can really be either or. X can just be in radians. All right, and then we're adding 1. So our period is 2 pi divided by 1/2, or 2 pi times 2 over 1, which is going to give us 4 pi. Our increment is our period divided by 4, so it's just pi. Our phase shift, I'm subtracting a negative pi. So I'm going to go negative pi. Okay, my vertical shift, I'm going to go up 1. So my midline is at y equals 1. My asymptote is, again, the period divided by 2. So I'm going to do 4 pi divided by 2, which is 2 pi. All right, so again, just like we did before, we want to start with our midline. Okay, my midline is at y equals 1. So that's my midline there. Then we're going to graph cosine. And again, our cosine graph would have an amplitude of 2. So I'm not going to go more than 2 above the midline and 2 below the midline. All right, and if you need to put in those kind of dotted lines, that's fine, but they're not really necessary. All right, so we're graphing cosine, which starts at 1, right? It's above our midline. It's our high point. So I'm going to go, I would start at 2 above my midline. Now, I'm shifting to the left pi, so at pi, I'm going to start 2 above my midline. All right, does that make sense? So when we're looking here again, my phase shift is pi to the left, so I start at pi to the left. Cosine, when it's positive, starts at a high point. So my high point is 2 above the midline because that would be the amplitude. All right, now my increment here is pi. So I'm going to go pi, I'm going to go hit my midline, and then I'm going to go another pi, and I'm going to hit my low point, and then I'm going to go another pi, and I'm going to hit my midline again. Okay, from here, I'm going to come back, and I'm going to hit my midline. So when our increments are pi, it just gets really spread far out. So again, our midline points are our asymptotes. And then our high points are the parabolas up. And our low points are the parabolas down. All right, we're going to do one more. And we're graphing a cotangent. So my period, remember, for cotangent, we're doing pi divided by that b value. So this is pi over 2. And my increment, we're doing pi over 2 divided by 4 or times 1/4 to get pi over 8. My phase shift, I'm subtracting a positive 3 pi over 2. And my vertical shift is down 3. So my midline is at y equals negative 3. Okay? My asymptote here is pi over 2 divided by 2, which is going to give me pi over 4. All right, so where we want to start, again, we're going to go ahead and get that midline value in there at y equals negative 3. So we're going to come down here to negative 3, and there's my midline. Then from here, we're going to remember we want to start cotangent with our asymptotes because it makes life easier. All right, so with my asymptote, my first one with cotangent usually starts on the 0. Now, I have a phase shift of 3 pi over 2. So instead of starting on the 0, I'm going to start at 3 pi over 2. So this is my first asymptote. Then from here, I'm going to go the length of one period to graph the next one, which is here because it's pi over 2. So each line is pi over 4. So 2 of them are going to give me pi over 2. So here are my asymptotes. And I'm just going to grab a couple more here. I'm not going to do them all. Okay? So now, I know that for cotangent, the midpoint between the two asymptotes on the midline is going to be that center midline point. Okay? Then halfway between here, my cotangent is positive. So halfway between here, we're going to go here and here. My number here is 1, so I'm going up 1 and below 1 on my graph above my midline. 1 above, 1 below my midline. So this is our graph here because we're going to hit here and here. Okay, same thing here. Halfway between high and low. And remember, cotangent is going in a negative direction when we are positive function. It is the opposite of tangent. All right. If you have any questions on this, please let me know. And I hope you guys all have a wonderful day. All right. See y'all later.